All right, guys, welcome back to our next lesson. Today, guys, we're going to look at chemical formulas. Okay, we're going to try to read a chemical formula, try to count the number of atoms in a molecule. We're going to try to differentiate between a molecule and a mole. And finally, we're going to calculate the mass of 1 mole of a substance or get the molar mass. All right. So let's start off with a chemical formula. So for example, here we got 3MgSO4. So that's our chemical formula right there. Right. So what does all these numbers and letters mean? Let's start with the big number in front. Okay. So let's look at this big number in front. It's the 3. All right. That is called a coefficient. Now, a coefficient, guys, multiplies everything to the right. Okay, so it multiplies all the elements to its right. So in our case, this 3 multiplies the mg, this 3 multiplies the s, oh, and then this 3 multiplies the o. All right. Okay. A coefficient tells you how many molecules there are of a substance. So this 3 right here can be read as 3 molecules. Okay, 3 molecules of MgSO4. So again, 3-MgSO4 can be read as 3 molecules of MgSO4. All right, and don't forget that big number in front, the coefficient multiplies everything to its right. So it multiplies the Mg, it multiplies the S, and it multiplies the O. All right. Now, let's look at 4. You see that little number 4 right there? Okay, you see that little number 4? That 4 is called a subscript and it multiplies the first thing to its left. So if you look at that number 4, the first thing to its left is the O. See it? So that means you have 4 O's. Okay, 4 O's. But remember, the 3 in front of it multiplies it. Okay, so that 3 also multiplies the O. So in total, you got 12 O's. All right. Now look. Okay, the S, the Mg, they don't have those numbers. They don't have subscripts. Well, actually, they do. They do have subscripts, all right? There's actually a 1 there. There's actually a 1 there, remember? But 1 is invisible in chemistry, so we never write it. Okay, so again, the coefficient, guys, multiplies everything to its right. In the subscript, multiplies the first thing to its left. All right, so let's try to count the number of atoms within this formula right here. All right, so let's look at this example right here. So how do you count the total number of atoms for each element inside a chemical formula? So if I were to ask you right now, how many mg's do you have here? Okay, how many s or sulfur do you have here? How many o atoms, how many oxygen atoms do you have here? So let's do that. Okay, first of all, again, what are the elements in this formula right here? I just said that. So again, the elements we have here is Mg. We got Mg, we got the S, and we got the O. All right. So if I were to ask you, looking at that formula, how many atoms are there for each element in the given formula? So how do you calculate that? All right. It's actually easy. There's a formula right there. Okay. You multiply the coefficient and the subscript gives you the number of atoms. All right, so let's start. Okay, let's start with the coefficient. So again, guys, the coefficient, that big number 3 in front, multiplies everything to its right. It multiplies the mg, it multiplies the s, and it multiplies the o. So for mg, it has a coefficient, yes. Okay, right there. So again, if you have a coefficient, it multiplies everything. Just put all that 3's down there. All right. So let's start looking at mg. All right. Does it have a subscript? Okay. You don't see anything. Remember, if you don't see anything, it's not a 0, it's a 1. So the subscript there is a 1. Remember, and let me write it down again. 1 is invisible. Okay. 1 is invisible. You can't see it, but it's there. All right. You can't see it, but it's there. All right. So mg, it doesn't have a subscript. Can't see it. But again, it's just a 1. It's invisible. All right. How about the S? What's the subscript for the S? 1. See it? Okay. And now if you look closely, the 4 Remember, it's a subscript. It multiplies the first thing to its left, the O. So that 4 is for O only. See it? Okay. So what is the total number of atoms? For Mg, you got 3 times 1 gives you a 3. Okay. How many S's do you have? I got 3. 3 what? By the way, what is that 3? It's 3 atoms. Don't forget. Since we're looking at each element, that's an atom. So 3 atoms Mg. How about S? 3 times 1 is 3. So again, 3 atoms of S, right? And then O, 3 times 4 is 12 atoms of O. You see it? And again, one more time, if you look at 3MgSO4, you can actually read that as 3 molecules of MgSO4. Okay, do you see now the difference between an atom and a molecule? So an atom, guys, is simply by itself. Okay, a molecule is a combination of two or more atoms. So if you put together several atoms, you get a molecule. All right. Okay, let's try another example. How about, for example, this one right here? Okay, what if we have this formula right here? Okay, oops, something's missing. Okay, the table is missing. Oh, there you go. Table's right there. Okay. So if you look closely here, guys, how many atoms are there for each element in the given formula? All right. If you look at the formula, we got Ca, that's one element that we have. We got a P, and we got an O. All right. Okay. Look closely. Do you see a coefficient? No, but remember, it's not zero. Never put zero. Okay. You do not put a zero if you don't see a coefficient or a subscript. Never put in a zero. Okay, instead of putting in the zero, it's a one because one, remember, is invisible. You don't see one. So actually, there's a big one in there in the front. You just can't see it. So one is invisible. So this is actually just one molecule, okay, of Ca3 parentheses PO4 2. See it? All right. Okay. So again, you can't see the coefficient, but there is a coefficient and it's a 1 because 1 is invisible. So we can actually put in 1 for all of them. So 1, 1, 1. That's the coefficient for all of them. Okay. So let's start with Ca. Do you see a subscript? Yes, I see a subscript beside Ca. So that 3 multiplies the Ca. See it? So 3 is the subscript. Okay. All right. Let's talk about, oh, I mean, we can actually finish this up. 1 times 3 gives me 3 atoms of Ca. So 3 atoms Ca. All right. Let's talk about the P. Okay. Do you see a coefficient beside, I mean, a coefficient, a subscript beside the P? You don't see a subscript there. Again, you can't see anything. Therefore, it's a 1. It's invisible. And that 1, remember, multiplies the P. So the subscript for P is just a 1. All right. Okay. How about the O? Do you see a subscript for the O? Yes, it's a 4. And remember, the subscript multiplies the first thing to its left. So the 4 multiplies the O. So I got a 4 for that. Okay. But wait a minute. Are we done? No. If you look closely, guys, there's a 2. If you look closely, there is a 2 right there. See the 2? It's a subscript. All right. And remember, I told you a subscript multiplies the first thing to its left. What is the first thing to the left of the 2? It's the parentheses. You see it? It's the parentheses. So how do you do that? All right. Remember, guys, a subscript outside the parentheses multiplies everything inside the parentheses. So what's inside the parentheses? I got P and O. So I need to multiply the P by 2 and the O by 2 as well. All right, is that clear? So again, a subscript outside the parentheses multiplies everything inside the parentheses. All right. So let's count how many p's do we have. 1 times 1 times 2 gives me 2 atoms of p. Okay. And then how many o's do I have? 1 times 4 times 2 gives me 8 atoms of O. You see it? All right. Pretty good. Okay. All right. Let's try this one right here. Okay. Pause the video. You can pause the video and try to solve this on your own. All right. We're back. So if you look closely here, again, what are the elements that you see in NaCl? All right. Guys, again, a capital letter tells you an element. All right. So if you look closely, I see a capital N and a capital C. That tells me there's only two elements in NaCl. It's Na and my Cl. Remember, a lowercase goes with a capital letter. All right. So I got two elements, Na, and I got Cl. All right. Look closely. Do you see a coefficient? Again, a coefficient is the big number in front of the formula. I don't see anything. So remember, that's a 1 because 1 is invisible. It's a 1. All right? It's a 1. So 1. And remember that coefficient multiplies all the elements inside the formula, everything to its right. Na and Cl. All right? So the coefficient 1 multiplies Na. It also multiplies Cl. All right. Let's look at subscripts. Do you see any subscripts? No. That means it's not a 0. Don't forget, it's just ones. So after Na, there should be a 1 here. You can't see it. It's invisible. After Cl, can't see it. It's a 1 right there. So again, a subscript multiplies the first thing to its left. So it multiplies the Na, multiplies the Cl. So you got a subscript of 1 for Na, a subscript of 1 for Cl. You see it? So let's try to figure out how many atoms do we have. 1 times 1, you got 1 atom of Na. And Cl, 1 times 1, you got 1 atom of Cl. That's how easy it is. Right, and don't forget guys, we read this as one molecule. Okay, we read this as one molecule of NaCl. All right, cool. Let's try another one. All right, how about this one right here? Didn't we do this already? Okay, I'll give you pause this video and try to figure this out. All right, so again, guys, how do you find again the elements inside this formula? Look for capital letters. All right, so I see M, P, and O, three different capital letters. That means three different elements. So again, a lowercase goes with the capital letter. So our first element is Mg. Our next element is P, and our last element is O. All right, let's start talking about coefficients. Okay, do you see a coefficient? Yes, it's that 3 in front. And remember, the coefficient multiplies all the elements to the right. So it multiplies the Mg, multiplies the P, and it multiplies the O. All right, so coefficient 3 for all of them. Okay, all right, let's start looking at subscripts. All right, Mg. Do you see a subscript after Mg? Yes, the 3. Therefore, that 3 multiplies Mg only. All right, so let's put that 3 right there. All right. Do you see a subscript after P? No. Therefore, that's a 1, and you can't see it. So again, that 1 multiplies the P, so 1. Okay. And then do you see a subscript after O? Yes, there's a 4 there, and that 4 multiplies the O. So you get 4 right there. Okay. All right. Are we done? Not yet. Because look closely, guys. There's a subscript 2. See it? There's a 2. Subscript 2 right there. But where is it? It's right after the parentheses. So the thing that it multiplies is in the parentheses. So again, a subscript multiplies the first thing to its left. In our case, it's the parentheses. And what did we say? A subscript outside the parentheses multiplies everything inside the parentheses. So what does it multiply? If you look closely, it multiplies the P and it multiplies the O. Okay, double check if we missed anything. Nope. All right, we're done. So let's start counting. So for Mg, 3 times 3, I got 9 atoms of Mg. Oh, atoms of Mg. Right, for P, it's 3 times 1 times 2. I got 6 atoms of P. And then for O, you got 3 times 4 times 2. That's 12, 24. 24 atoms of O. Okay, you see it? And this is how you do counting atoms. All right, and don't forget, one last time, the big 3 in front tells you that's the number of molecules, so you can read this as 3 molecules of Mg3 PO4 2. See it? All right, cool. All right, so one more time. All right, see that big 3 in front, the coefficient, okay, that multiplies everything to the right. Again, guys, we can read this as 3 molecules of, whatever the formula is. In our case, it's MgSO4. Okay. But we can also read this as 3 moles of MgSO4. So again, this is 3 moles, okay, of MgSO4. What is the difference between moles and molecules? All right. Guys, moles is different from molecules. Molecules is when you have several atoms that you combine together to form a substance. That's a molecule. A mole is more of a measurement unit. It's like a dozen. It's like a kilogram. So it's actually a measurement unit. Okay. So a mole is a standard scientific unit for measuring large amounts of very small quantities like atoms, molecules, or particles. All right. Most of the time, that number is referred to as Avogadro's number, after the physicist named Amadeo Avogadro. It allows scientists to equally measure out two elements with totally different masses. All right. So, in summary, what is the mole? What is it equivalent to? All right, a mole is actually equivalent to 6.022 times 10 to the 23rd power atoms, if we're talking about atoms, molecules, if we're talking about molecules, or particles, if we're talking about particles. And that number is huge. If we stretch it out, this is 1 mole. 1 mole is equals to 602.200.000.000.000.000.000 of something. Okay, and that is a very, very huge number. All right, so if I started to, let's say, count how many atoms are there in 1 mole of oxygen, that's going to take me more than my lifetime to actually count all these numbers, right? Okay, if you had this amount of money, you wouldn't, and you started counting your money right now, $1 for every second, it's going to take you like several lifetimes to actually just count your money. All right, that's a lot of money right there. Okay, so it's actually very cumbersome, okay, for scientists to actually count these numbers. Okay, it's actually very, very cumbersome to count these numbers. All right, so what do we do? So most of the time we do conversions, right? So let's do conversions first. Okay, so what if, oh, by the way, these are some examples of how big a mole is. After talking about money, you can look at these examples right here. Okay, so for example, if we were to get 1 mole of soda cans, it would cover the surface of the earth in a depth of 200 miles. 200 miles, that's taller than the tallest building on the planet. Okay, so that's a lot of soda cans right there. All right, so there you go. So these are basically what your mole is. All right, so let's do some conversions. All right, so let's do some conversions. All right, so remember we said 1 mole is equals to 6.02 times 10 to the 23rd power atoms, molecules, or particles of something. Okay, right? But again, like I said, this is actually very cumbersome to count. So if you want to count this, it's going to take you more than your lifetime. Okay, so what do scientists do? Instead of counting atoms, they instead measure the mass. Okay, they do mass conversions. All right. So what they do is they find the mass of 1 mole of a substance. All right. So, for example, if I were looking at, let's say, calcium carbonate, or glucose, for example, if I was looking at glucose, I wouldn't count all these particles of glucose. I would get the mass, okay, of glucose. Remember, glucose is sugar, right? Instead of counting each and every molecule of glucose, we don't really do that. What we do is we get the grams, right? How many grams of sugar? What's the mass? So that's what we do. Instead of measuring out how many molecules of glucose there are in a mole, we actually just get the mass, like so, right? So 1 mole is how many grams of a substance. All right. That is basically that mass that we get is basically what you call the molar mass. Okay. Why? Because it's the mass of 1 mole of that substance. So when we say get the molar mass of a substance, we're actually looking at the mass of 1 mole of a substance. All right. So how do you get the molar mass? And here we go. So that's gonna be our lesson for the last part today. So how do you get the molar mass? The mass of 1 mole of substance. All right. It's actually easy. There's a formula. Okay. To calculate the molar mass. Oh, by the way, the molar mass is also called the formula weight, molecular weight, or formula mass. Either way, it's the same thing. It's talking about the mass of 1 mole of substance. All right. How do you calculate the molar mass? It's easy. When you look at a formula, you look at each atom, each element, and then you count the number of atoms for each element. Okay, multiply its atomic by its atomic mass to get the element mass, the mass for that element, and then you add them all up to get the total, which is your molar mass. Again, the formula is, so when you look at the formula, per element, for every element you count the number of atoms, okay, multiply it by its atomic mass. And where do you get the atomic mass? You get the atomic mass from the periodic table. So let's grab a periodic table really quickly. All right. So if you look at the periodic table right here, guys, the atomic mass, or the atomic weight, it's right there, is the bigger number inside the box. It's right there, atomic mass. Okay, you see it? It's right there. The atomic mass is the bigger number inside the box. So for example, if we were looking at boron, you got 5 and 10.82. See this box right here? There's two numbers inside, right? The atomic mass would be the one at the bottom, the bigger number right there. So that's the one that you need. So we need a periodic table. So don't forget. So make sure you have this periodic table. You should have it in your notebook. All right. Here we go. Let's try this out. Let's put this into play. All right. Let's try it out. For example, guys, I want to calculate the molar mass of MgSO4. All right. Look here. So I want to calculate, guys, the molar mass, okay, of MgSO4. Again, guys, this is the formula mass, the formula weight, okay, whatever you want to call this. I want to calculate the formula mass for MgSO4, right? So that means 1 mole, okay, of MgSO4 is how many grams? Is equals to how many grams, all right, of MgSO4. All right, so that's what we're going to figure out. First things first, what are the elements in MgSO4? Again, like I said, look at capital letters. It's going to tell you how many elements there are. Each capital letter you see, that means you have one element. So I got Mg. Remember, lowercase goes with a capital letter. So you got Mg, you got an S and an O. All right. So let's count the number of atoms. You should already know this. Subscripts multiply the first thing to its left. Coefficients multiply everything to the right. And if you don't see a subscript, the subscript is a 1. So let's look at Mg. How many Mg's do I see? Again, there's no coefficient, so that's just a 1. Do you see a subscript on Mg? No, so there has to be a 1 there. 1 times 1, I have only one atom of Mg, just one. See it? Okay, all right. Let's grab a periodic table and look for Mg and find its atomic weight, atomic mass. So let's grab our periodic table again. All right. Our Mg is right here. Okay, and we can clearly see it's 24.305. All right. So I'm going to grab that. Atomic weight for Mg is 24.305. And then right there. Okay. And then you multiply it, the number of atoms by its atomic weight or atomic mass. Okay. And you get the element mass. So 1 times 24.305, I get 24.305. This is the unit for this is AMU, atomic mass units. Okay, atomic mass units. But most of the time we use it. We just use grams for it. Okay, because when we talk about 1 mole, we're talking about grams. All right. So let's do the same exact thing with S. How many S's do you see? I don't see a subscript, therefore it has to be a 1. Again, the coefficient, there's nothing there, so it has to be a 1. 1 times 1, so therefore you have 1s. Okay, grab a periodic table, find its atomic weight. You're going to see it's 32.066. You have to copy all the numbers there. We're not going to round off because there's a problem most of the time when people round off, so we're just going to use all the numbers. All right, 1 times 32.066, I get 32.066. Now look at O. Okay, again, coefficient is 1, right? But you see the 4? That multiplies the O. So therefore, I got 4 O's. Grab a periodic table, look for the mass, and you get 15.999. Multiply 4 by 15.999, you get 63.996. All right. So what do you do with all these element masses? You add them all up. Okay, you add them all up, and you get 120.367. See it? All right. What does that mean? That means that 1 mole, okay, of MgSO4 has a mass of 120.367 grams of MgSO4. Right? You can also say that the molar mass of MgSO4 is 120.367 grams per mole. See it? And that's how you calculate the molar mass. So again, molar mass is the mass of 1 mole of that substance. All right? Okay, let's try out another example. We're going to try out 2 more examples, and then you can start on your own worksheet. All right? So look at the formula here. I mean, look at the question here. Find the mass of 1 mole of Br atoms. All right, so again, we want to look for Br. Okay, so what's the element there? Just Br. Okay, look closely at that formula. How many Br do you see? I see only one. All right, see it? There's only one. There's no subscript, there's no coefficient, therefore it's just one. Okay, grab a periodic table really quickly and find the mass, atomic weight of Br. And you're going to see it's 79.904 AMU, atomic mass units. 1 times that, and you get 79.904. And that is the answer already, because there's only one element. That means 1 mole of Br has a mass of 79.904 grams, okay, of Br. You see it? All right. Let's try one last one, and then you can start on your worksheet. Okay. Find the formula mass of Ca3, parentheses, PO4, parentheses, 2. Okay. First things first, let's determine all the elements that we have. We got Ca, P, and O. So by now, you should know which elements are, right? Looking at the formula, again, capital letters will tell you what are the elements. Let's start looking at Ca. How many Cas do we have? If you said 3, you're right. Okay. How many atoms of P do we have? If you said 1, that's wrong. Remember, it's inside the parentheses. So the number outside the parentheses multiplies it, so it's 2. See it? All right. Look at O. How many how many atoms of O do you see? If you said 6, that's wrong. If you said 4, that's still wrong. Okay? It should be 8. Why? Because again, there's a subscript 4 that multiplies the O, but since it's inside the parentheses, which is multiplied by 2, so therefore you got 8. All right? Okay, really quickly, go through the periodic table and find the atomic masses or weights. Right. For Ca, you're going to get 40.078 for the mass. For P, you're going to see that it's 30.974. And then for O, it's 15.999. All right, what am I supposed to do? You multiply and find the answer. So for Ca, it's going to be 120.234. Okay. For P, it's going to be 61.948. And then for O, it's going to be 127.992. You see it? All right. Now what do you do? Again, the final answer, you add them all up, and it's 310.174. So again, guys, this is your answer right there. And again, to read this, that means you got 1 mole of Ca3PO4 has a mass exactly 310.174 grams of Ca3PO4. All right, and that's how you calculate molar mass. Guys, it's very important you know how to do this because if you know this, okay, when you look at the final answer, what does it remind you of? Okay, it reminds you of a conversion factor, and we're going to use this to convert, okay, the masses of different substances into mole. All right, so again, don't forget, you need to know how to know this. You need to know how to do this. All right, so go ahead, practice, 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 practice. Practice makes perfect, so make sure you do the practice work. And then if you have any questions, please don't hesitate to email me, and I'll get back to you as soon as I can. All right, perfect, very good. Hopefully you learned everything today, and I'll see you all next time.